Hi, I'm Jack Koenig with Graco. Today I'd like to show you how to build an MSP divider valve assembly. Before we get started, let's talk a little bit about personal protective equipment, or PPE. There's not much required for this job because we're just turning some wrenches, but we still, anytime we're wrenching, want to have our safety glasses. And when we test these parts in the factory, we test them in oil. A lot of the oil residue is still on them when they ship. So if you don't want your hands to get oily, consider wearing some gloves and maybe even an apron to protect your shirt. But that's about it. So let's now take a look at the components in this assembly before we start putting it together. The major components of an MSP valve are the inlet section, which is the one without O-rings on it, and the inlet port opposite that side. Then the intermediate base sections, these have one side with O-rings, one side without, and the outlet ports are here. This is the end section. There is no port on it. We have an optional port that's off to the side with an 1/8 inch thread, but most people don't use that. And then there are the 9 O-rings. Speaking of that, every time we put one of these things together, we're gonna check for all 9 O-rings being present. If one's missing, then you need to grab an O-ring from a different valve and order a replacement. Each MSP valve needs 3 tie rods, and they need to be the correct length for the assembly. Since we're building a 4-section valve, we need tie rods that are the right length for 4 sections. Each tie rod needs a nut, and that means we need 3 nuts. One word of caution, do not use a pliers and put it onto your tie rod, because if you squeeze this hard enough, it will make marks, and that's gonna mess up your assembly when you're trying to slide the end sections over the tie rods. Next, we have our valve sections. Each section includes 2 of these mounting screws, the cross port plate, which comes with longer screws because it accommodates the width of that plate. So 2 of the screws from the valves will end up getting set aside. I'm also going to put a bypass section in this. This doesn't have any working piston in it, so it's not a working section. It's just a space holder so that your valve can be expanded later. Lastly, we have some plugs for the unused outlets. Because some of these are S or single outlet valves, we're going to need to plug one side, and then also with the cross port, we'll have to plug that. And then on the bypass, those need to be plugged as well. Along with the plugs, we want to make sure we have some liquid thread sealant. Let's cover some accessories. The visual indicator, part number 563251, the 17L983 solid state proximity switch. Then this is what I kind of call the old Trabon proximity switch. Now this is the really old school way of doing it. This old micro switch, it's just a limit switch with a clamp that needs a valve with the cycle pin indicator on it. And last but not least, we have our performance indicators, which install in the indicator ports on the front of the valves. Step 1 is to take one of the tie rods, take a quick look at the threads, make sure they're clean and that they don't have any chips on them. And then we're going to go from the side away from the inlet port. So we're going to start at the other side where we have the 9 holes and place one of the tie rods in here and just finger tighten it. Again, do not put a wrench on this, no pliers. We don't want to mark up or scrape the plating. We just want to make sure that this gets to flush or a little bit past. If it jams up, then you need to clean the threads. Maybe you just have a chunk of sand or silt or something on your threads and you need to back it out and clean that out. And that is another point, is it's good to do this in a clean environment. If you do this in a dusty environment, you're going to have problems with your valve because divider valves do not like contamination. Once these 3 are there, we're going to take our first intermediate base section and check that all 9 O-rings are there. We're going to line up the 3 mounting holes and slide that on. Make sure that the O-rings are facing the inlet, because the inlet doesn't have O-rings, so it needs those O-rings to seal that mating surface. So now we'll just take the next one, check for O-rings, slide that on. Again, check for O-rings, slide that on. Last one, since this is just a 4 section, we're doing our 4th base, slide that on. And now same thing with the end section. Looking for 9 O-rings, they're all there. We're going to slide that on. Place the valve down. Might need to put a little pressure on it so that we can get our nuts started to get a little bit of thread engagement there. This is where the nut driver comes in handy, because now we can get these down to tight without over torquing it by using the nut driver. Now we'll just torque these. You're going to want to have some kind of a flat surface where you can hold this down. So now we're ready to install our valves. On this first section, I'm using my 40T with the cycle indicator pin over here. Just gonna put a couple of turns on that. For the next valve, I've got a 40S, and here I'm gonna put the cross port plate. So I'm setting aside the original mounting screws and lining up the mounting holes on this cross port right. with my 40S and then dropping the mounting screws down into the holes. Here's a 5S valve, and now finally our bypass. We're going to use a 3/16 hex key. You can feel when you have the O-rings compressed, and you can even feel when you're compressing the O-rings versus when they are compressed, and all of a sudden you feel a little more resistance. So just stop when you feel that extra resistance, because that's where you're going to want to now come back with your torque wrench. If you want to, it's okay to use it the other direction too, if it's quicker to spin it that way, but just again, feel for that resistance so that you're not over tightening these. The larger the number, so 40S and 40T being the largest ones, they are the most susceptible to warping when they're over torqued. 5S's are more forgiving because there's less piston and more block, but the 40s have the biggest pistons, which means they have the thinnest cylinder walls, and they are the most susceptible to over torquing. Now my hex key and my torque wrench, and set my torque wrench properly, and now we're going to just torque these on. You can see I'm not having to turn far to get the torque wrench to engage, because the way I did it by hand there made sure I wasn't over torquing it, and I got it right in the right sweet spot. So these are all torquing really nicely. We're almost done. The last step now is, because we have some unused outlets, they need to be plugged. The first valve, being a 40T, doesn't need any plugs, but this 40S with a cross port needs to have both sides plugged. So I'm going to put some pipe dope on each of these plugs. These are also 3/16 inch. There's no torque spec for these because it's a tapered thread, so you just need to get them in there good and tight and just make sure they don't leak. Next, let's install some cycle indicators. We need to remove the plug from one end of one of the valves. It doesn't actually matter which one, whatever fits in your location best. Sometimes these can be seized on. This one came out pretty easily, but that's where it's also nice to have one of these hex bits and maybe a breaker bar, so that you can get in here and put some more torque on that than your typical little hex key will do. But this one happened to be in there not too tightly, so it's coming out for me. And this is now where I already removed this one, so we can see here if we want a visual indicator. This just threads in here, and the piston's on this end, so it's fighting me a little bit, but it'll go in there. And this again here, these are O-ring seals that don't need a ton of torque, which is where it'd be hard to get a torque wrench on this one. So again, just get a little adjustable wrench, and once you have it finger tight, just give it a little more of a snug, and don't try to break it, because you can break it if you try to, but if you don't try to break it, they're pretty rugged. And then whether it be the solid state proc switch or the Trabon old school switch, these guys both just thread into the same ports. It's good to put a torque wrench on these because they're a hex, but for the sake of time, I'm not going to demonstrate torquing. We've already done that on the other components. So here I'm going to just tighten it up so that it's, as soon as there's metal on metal where the O-ring is compressed, it's good. Let's put our limit switch on the spud of the cycle indicator pin. If this clamp doesn't want to slide over, you may want to loosen this. It's a 7/64 inch hex, and just force it on there so that it covers the whole smooth part of the spud, the rounded off part, and goes right up against the hex. There's no torque spec for this. If you over tighten it, you can crack the bracket, and then you need a whole new switch, because we don't actually sell that bracket separately, because it's not a part that people need very often. But you don't need to crank it on real hard. You just get it on there enough that it's not going anywhere. And now anytime that pin moves back and forth, it'll actuate the switch. I'm not going to cover wiring in this video. That's a subject of a different video. And I do have some videos about wiring various switches out on our YouTube channel, so check those out. But now let's move on to performance indicators that install in the indicator ports. Indicators go in the indicator ports. We've got two indicator ports, which are alternate outlets. They're internally plumbed directly to the outlet ports. These are also a 3/16 hex, so we keep that consistent. When you have a T valve, you'll need two of the indicators because you need one for each outlet. If you have an S valve, you only need one indicator because the outlets are combined. And if you have a cross port where you're not using either outlet, then you don't need an indicator for that. So let's do one of these automatic reset indicators first. I'm going to use my nut driver, like I was saying before, to just get that in there nice and snug against that O-ring seal where That's all you really need. You don't need to be over tightening it. This is not a tapered thread. It's a straight thread with an O-ring. So we're just going to get it snug. And then we're going to do the same thing where we take our torque wrench and torque it to spec. These guys already are torqued plenty good. Oop, that one need a little bit. There we go. Good to go. Similar process with the turkey poppers or the grease set indicators. On this one, I want to go this side because I plugged the left side. So when we look at what's plugged here, we've got all these plugged over here. So this port on this valve is plugged. The only one that's open is the one here behind the proc switch. So this is where we want to have an indicator connected to that port that's 90 degrees from the outlet. At this point, the valve is ready to be tested. We want to test it with a pump and a gauge and make sure that it does not require more than 175 psi to cycle the valve. If it requires more than 175 psi to cycle, then something is probably over torqued. So the best thing to do would be to loosen the mounting screws and maybe even the tie rod nuts, and then retighten them correctly to the proper torque and test again. Larger valves like 40T and 40S valves may need to sit overnight if they've been over torqued for a while, but usually if you let them sit for a day, they will bounce back into shape. With that, we're ready to close out this video with just a few more details. Among the tools required, take note that I recommend a torque wrench that is set by inch pounds, not foot pounds, because 5 foot-pounds is going to be hard to set on a normal torque wrench. But if you have a torque wrench that measures in inch pounds, you can set it to 60 inch pounds, and that's 5 foot-pounds. The most popular threads for the inlet and outlet ports are the NPSF threads, and these are compatible with NPT and NPTF male fittings, but we also offer BSBP and SAE O-ring Boss. I hope this video has been informative and helpful. Please contact us with any questions, and thank you for choosing Graco.